Lesson 6-3, multiplying fractions, and in this lesson you learn to multiply fractions. Why is it important? Because knowing how to multiply fractions can help you make half of a recipe if you cook. Let's take a look at this activity, and you can pause when necessary. So you can use grid paper to make an area model for a multiplication of fractions. The diagram at the right models the product 2/3 times 5 over 6. Well, it doesn't right now, but I'll tell you when. I'll tell you how it does. Okay, so we have a rectangle that is a 3 by 6 rectangle. Why is it a 3 by 6? Because the denominator of 2/3 is 3. Denominator of 5 over 6 is 6. So you divide your rectangle into sixths and thirds. Okay, so we will get 2/3 of that rectangle, which is this one. So 2 out of 3 has been shaded, and we will multiply it with 5 over 6. That means 5 parts of the rectangle out of 6 right there. Okay, so 2 rows are shaded yellow, not really yellow. In this case, it's shaded green to represent 2/3. The rectangle has 6 columns that represent 6. 5 columns are shaded blue. Now that's blue. That represent 5 over 6. Notice that the overlapping area, okay, so this is our 2/3. Let me write it down first. Okay, so the green part represents 2/3. This one right here represents 2/3, and the blue part represents 5 over 6. Okay, so 5 columns are shaded blue to represent 5 over 6. That notice that the overlapping area is 10 over 18 of the rectangle. If you count the number for squares that have been shaded, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 of them out of 18. Okay, it's shaded green more or less, a different color probably. So the product of 2/3 and 5 over 6 is 10 over 18, and we put that in simplest form. That would be 5 over 9. And that's how we use models to multiply fractions. Okay, now it's your turn. Get your own grid paper, and let's do the same thing. Okay, let me take this out. Let me take out that one. Put that there. Let me take out this square. Put that there, and let me take out this square. Put it there. Okay, so let's try this one. Okay, use grid paper to make an area model of 3/5 times 1/4. That means you need to create a rectangle, okay, and divide it into fifths and fourths. And luckily for you, I did it. So 1, 2, 3, 4, and 1, 2, 3, 4, 5. Okay, why? Because the denominator is 5 and the denominator 4. So I divided my rectangle into fifths and into fourths. Okay, so how did you represent 3 over 5? So 3 over 5 is represented this way. 3 out of 5 are shaded. Okay, how did you represent 1/4? And I just got this and put it there. 1 out of 4 has been shaded. Okay, what is the value of 3/5 times 1/4 that you found using grid paper? So if we count the number of squares where both of them overlap, 1, 2, 3, okay, and 3 out of total number of squares would be 20. So it will be 3 over 20. Write a description how an area model shows a multiplication of fractions. That's easy enough. So basically what happens is this. When you're multiplying fractions, if you notice, you simply multiply the numerators, okay, and the denominators, and you get the product of 3 over 20. Okay, and what happened there? So let's clear that again. You get the product of 3 over 20 right there. Okay, so with that in mind, we can now learn our concept in multiplication of the multiplication of fractions. Okay, so an area model shows what happens when you multiply fractions. You'll get the same results if you multiply fractions as shown below. 2/3 times 5 over 6, okay, is the same as multiplying the numerators. 2 times 5 and multiplying the denominators, 3 times 6. You'll end up with the same product, 10 over 18, and simplify that, you'll get 5 over 9. Which brings us to the rule of multiplying fractions. To multiply fractions, multiply the numerators and multiply the denominators. So in symbols, for fractions a over b and c over d, where b is not equal to 0 and d is not equal to 0, again, these are just restrictions so that our fraction will not become undefined. Okay, we know that you simply multiply a and c, so that becomes ac over bd. Okay, multiplication of numerators and multiplication of denominators. Okay, so if the fractions have common factors in the numerators and denominators, you can simplify before you multiply. Okay, so one more thing that we can do, this is the rule for multiplying fractions, but one thing we can do so that you don't have to simplify after you've found the product, if the fractions have common factors in the numerators and denominators, you can simplify before you multiply. Okay, so let's take a look at example number 1, see how this works. Let's solve 5 over 12, sorry, equals or times 2 ninths. Okay, use the rule, method 1. So you simply multiply 5 times 2 over 12 times 9, end up with 10 over 108. Simplify that, you get 5 over 54. Method number 2 is what we learned in the last paragraph. It says there, if there are common denominators, we can cross cancel, like here in the very bottom. Very bottom. What did I do? Let's undo that and let's do this. Okay, go back here. So we have 5 over 12 times 2 over 9. That didn't work out well. So what we want to do is we want to find common factors, GCF in this case. So if you notice, 2 and 12 has a GCF. Okay, that means a GCF of 2 over 12 will be 2. So you divide 12 and 2 by its GCF, which is 2. 2 divided by 2 is 1. 12 divided by 2 is 6. Okay, and if you notice, there are no more GCFs. So that's exactly what happens. GCF of 2 and 12 will be 2. So we divide it with the GCF, and we simply multiply 5 times 1, which will give us 5, and 6 times 9, which will give us 54. If you notice, we didn't have to simplify. We already have the simplified answer. So you can use the multiplication skills that you've developed with integers and fractions to multiply negative fractions. Let's take, for example, 3 and 3/8 and negative 5 and 1/3. Again, we go back to our estimation skills and see if our answer will make sense later on. We estimate 3 and 3/8 to become 3 and negative 5 and 1/3 as 5. So we multiply them, our answer should be close to negative 15. Okay, again, we cannot multiply mixed numbers. Okay, so what we need to do is we need to convert each number into an improper fraction, and the improper fraction of 3 and 3/8 would be 27 over 8. Why? Because 3 times 8 plus 3 will give us 27, and we simply keep the denominators. 5 times 3 plus 1 will give us 16, so the improper fraction of 5 and 1/3 will be 16 over 3, and put the negative sign. Now we can multiply. Okay, so after renaming them, if you notice, we can find the GCF. Look at 8 and 16. Okay, 8 and 16 has a GCF of 8, so we divide that by 8. So 8 divided by 8 will be 1. 16 divided by 8 will be 2. And 3 and 27, the GCF is 3. So 3 divided by 3 is 1. And 27 divided by 3 is 9. Okay, so we have 9 times 2. It will give you, okay, negative 18 over 1, because 9 times negative 2 will give you negative 18, and the simplified form would be x equals negative 18. And if you compare with the estimate, it's very close. Let's take a look at letter B. A equals negative 1 and 4/9 multiplied by negative 2 and 3/5. Okay, we estimate this one to become negative 1, closer to negative 1, that mixed number, and this is closer to negative 3. So our estimate answer would be close to 3. Okay, so we have negative 13 over 9, which is the improper fraction of negative 1 and 4/9. and negative 13 over 5. Okay, and if you notice, there are no, okay, GCFs between 9 and 13 and 5 and 13. So we simply multiply straight. Negative 13 times negative 13 will give you a positive 169. 9 times 5 will give you 45. So you end up with 3 and 34 over 45. That is a mixed number of 169 over 45. So the product of two rational numbers with the same sign will always be positive. A negative times a negative. And let's take a look at example number 3. Okay. And example number 3, Manuel Mendez is the chief cook at the U.S. Military Academy at West Point, New York. He and his staff of 96 work to feed 4,500 cadets 3 times each day. They have a Sloppy Joe recipe which calls for 7.5 pounds of ketchup and serves 100 people. How many pounds of ketchup are needed for one meal of Sloppy Joes? So the recipe serves 100 people, so the staff will need to purchase enough ingredients for 100 divided for 4,500 divided by 100, or 45 batches of Sloppy Joes. Why 4,500? Because there are 4,500 cadets, and one recipe is for 100 people only. So you will need 45 batches of Sloppy Joes. And knowing that, okay, we start 47 times 7 and 1/2, and we know that we need to convert 7 and 1/2 into an improper fraction. So you have 45 over 1 times 15 over 2. We don't see any GCFs, so we multiply straight numerator and denominator. Okay, we end up with, okay, again we just rename that 7 and 1/2 as 15 over 2 and 45 as 45 over 1. So just multiplying it directly across, we end up with 675 over 2, or 337 and 1/2. Okay, so we have 337 and 1/2. Okay, pounds of ketchup are needed, okay, to feed 4,500 cadets. Okay, and let's take a look at the last example. Example number 4, which is at the bottom of this one right here. You can evaluate algebraic expressions involving multiplication of fractions in the same way that you evaluated expressions using integers. But before we go to the last example, okay, our secret name for the day would be Pope Francis. Pope Francis. Let's proceed with example 4. Evaluate expression ab squared if a is equal to 1 and 1/2 and b is equal to 2/3. Again, when you hear the word evaluate, it simply means find the value of, and there are 2 steps to evaluate, meaning to substitute and then to simplify. Let's substitute the values of a and b. So this becomes 1 and 1/2 and 2/3 squared, because a is 1 and 1/2, b is 2/3. Okay, remembering in order of operations, exponents go first. So we need to do 2/3 times 2/3 first. Okay, so we end up with 3 and 3/2 will be the improper fraction of 1 and 1/2, and 2/3 squared will give you 4 over 9. And we can see GCFs here. Okay, and the GCF of 3 and 9 is 3, so 3 divided by 3 is 1, 9 divided by 3 is 3. GCF2 of, okay, GCF2 of 2 and 4 will be 2, so 2 divided by 2 is 1, 4 divided by 2 is 2. So we simply, okay, multiply 1 times 2 will give us 2, and 1 times 3 will give us 3. Okay, so that is the value of that particular expression. All right, and that's the end of our lesson. Thank you for watching.